All right, perfect. Okay, let's get started. Uh, Hello, everyone, and welcome. I am Tin. I am the president of Finding Five, and I believe some of you have interacted with me, right? So we have known each other through emails, support emails. And if you're new to Finding Five, we are a nonprofit dedicated to making behavioral research more accessible. And so we believe technology should, empower science, not complicate it. And our platform helps researchers design and run online experiments efficiently without requiring extensive programming skills. So we are committed to doing this and to make sure that behavioral research is reproducible and making it easier to collect high quality data at scale. Today, and I think everybody should have the same view as I do, which is Dr. Jennifer Roche at the center of the screen from Kent State University. Uh, Jenny is a friend of mine, and she is also an associate professor of speech pathology and audiology. She is a cognitive scientist whose research focuses on how we communicate and learn in social context, right? And when I first knew Jenny, her first research project that I got to know is how innuendo works in language perception, which was really fun. She is a head of the lab, the Miscommunication and Dialogue Interaction Lab at Kent State. But what makes her research special is that she uses techniques like mouse tracking a lot, right? These uh, mouse tracking techniques, when it is not possible to do eye tracking for some reason, it helps us reveal insights into the cognitive processing and the decision making in real time. So I know relatively little about it. And with all of this being said, I'm gonna give the microphone to Jenny, so she will share the best practices for designing mouse tracking studies online. Finally, just want to remind everybody again, we are recording this video, right? So I have set it up so it should only capture Jenny, me, and the slides. But if you don't want to be part of the recording, right, you can turn off your webcam just to ensure privacy. Now, please take it away, Jenny.
Thank you, Ting. Can you hear me okay? Perfect. So Ting, that was really nice. I can't believe you remember the first study. That was a long time ago. Very long time ago. So thanks for remembering that. Well, thank you everybody for coming. The purpose of this, webinar, I'm really going to try to give you a brief introduction into the world of mouse tracking and some of the things that I've experienced going from in-lab data collection to using Finding Five to collect data online. So I just want to give props to Ting for this and his team because you guys really stepped up for us during the pandemic. And so so I do eye tracking research, but I also do mouse tracking research depending on the project that I'm working on, the type of research question. And when the pandemic hit, I had a number of students that needed to finish theses and dissertations. And I messaged Ting and I said, hey, is there any way we can get mouse tracking done on Finding Five? And he goes, yeah, let me see what I can do. And so what we did almost immediately, once the mouse tracking was implemented, we started replicating or attempting to replicate a project. And so what I'm going to do is I'm going to give you a little bit of a background, theoretical background, very light background on the theoretic underpinnings of mouse tracking. And then I'm going to show you a little bit of data from the lab. And then I'm going to talk a little bit about some of the methodological considerations that you have to make when you're programming studies in Finding Five specifically for mouse tracking. Also, something that you'll notice, I will have QR codes that pop up on different slides where I provide you essentially links to things. So you'll see the QR code that's down in the bottom right-hand corner. This will also happen at the very end if you decide, oh, maybe this is useful, I'd like to have it. This links directly to the slides that I have today. So, please feel free to access them that way. But again, they're going to be at the end in case you miss it. Okay. So, really, to just start, I want to give everybody kind of a brief history of computer mouse tracking in the cognitive domain, so in cognitive research. So, computer mouse tracking really emerged from eye tracking research and methodologies that people were really looking at different ways that we can really measure cognitive processing. Much of what we do is indirect, so we have to come up with unique ways to be able to really figure out what is going on in people's heads. So, originating somewhere like mid 1990s, eye tracking that was initially used to study word and sentence processing in visual world tasks. But by the early 2000s, cognitive scientists were exploring more affordable alternatives. So anybody that's looked into the cost of an eye tracker, I mean, some 10 years ago when I got my eye tracker, it was over $30,000. This is not something that we often have access to have those funds to be able to pay for expensive equipment. So there were some foundational connections between perception and action that were established early in the 2000s, specifically by Landon Hayhoe, where they came out with this really important paper that talked about how the eyes are really important in guiding and directing the hand movements when completing everyday tasks. And this led to further insights by Spivey and other colleagues to look at alternative measures to cognition, finding results that are comparable to eye tracking during sentence processing tasks. And so this method that they found was mouse tracking. They found that mouse tracking was actually a corollary of what we do with our eyes. Now, there are going to be some, distinctions in how data is collected and what that data means. But in terms of measuring cognition, there's a strong relationship between what your eyes are doing and what your hands are doing in computer mouse tracking. And nearly 2 decades later, hundreds of studies have employed mouse tracking to measure human cognition across decision-making and social cognition domains. And it's often called the poor man's eye tracker. That's what mouse tracking is often referred to as. And it's a viable method to reveal the mind in motion. So it allows us to track what's happening in cognition in real time as someone is making a decision. And this method provides an economical yet effective way to observe how cognitive processes unfold over time, making it a more popular, and it was made more popular by John Freeman in around 2010, where he created a free open source program for in-lab mouse tracking studies. And I'll provide that a QR code for you to be able to link John Freeman's mouse tracker because it's still freely available. I don't know how often he updates it, but I was able to recently just download it on my computer. And I still actively use Mouse Tracker in the lab when needed. But what I want to kind of draw your attention to, what happens in mouse tracking, just to get kind of a flavor of what happens. So McKinstry, Dale, and Spivey in 2005, they ran a study where they pulled questions from the mind pixel corpus. The mind pixel corpus is this corpus of thousands of questions that were normed by millions of people for truth values. And so one of the questions that was in the mind pixel corpus is murder is sometimes okay. Don't quote me on that. It's something to that effect. There was another one that said something about do you have to brush your teeth every day? And people were like 50-50 on that one. So which, that's there's a point for me to tell you that. So the thing is that when you ask someone, is murder okay? They're likely to say, it is never okay. Because that is a socially acceptable response. Okay, that's fine. But the thing is that deep down inside in our brain, in the implicit non-conscious areas of our brains, we might go, oh, actually, there might be some cases where murder might be okay, like in self-defense or in wartime and things like that. And so what mouse tracking is going to afford us is the ability to see if there are alternative representations in the brain competing for activation, right? And so mouse tracking allows us to do that. So if you see on this, if you look on this left-hand panel, what you see is a curvature that's pulling towards true, even though the final response is false. So instead of just saying, okay, well, the answer is false, everybody thinks murder is not good, you actually see, well, sometimes people kind of think that it might be okay. On the right panel, I'm showing you like an alternative of what could happen. So for that item, and I'm sorry if that's really small, but what it says is a dog is a mammal. So that is very easy for someone to answer. There's no competition in cognition, so you see a more fluid trajectory towards the response option. And so the purpose of this is to show that when there is ambiguity or maybe the opportunity for alternative response options, you actually see this competition occur between the two options that are presented as it unfolds over time. Now, this is a really nice looking mouse cursor trajectory. They're not always that clear or that smooth, but they sometimes are. If it has to, when it comes to like social decision making, things are a little bit messier. But this is this is kind of a good representation of what it would look like. If you are interested in in-lab data collection, if you've got a couple of Windows-based computers, you can use John Freeman's Mousetracker. This is, it's a great program, but the thing is, it's limited. You can only use it on Windows, you can't use it on Mac, and you can't use it over the internet. But it's still a reasonable system to use if you're interested in getting into Mousetracker. And John Freeman has amazing tutorials on how to use the system. And on one of their pages, there's like 500 manuscripts that have been published with Mousetracking. Okay, so a little bit more information or a little bit kind of a background of the theoretical framework in computer mousetracking is dual process models of information processing. And so where we start from this is from a perceptual theories framework. And what that kind of is saying is that the primary goal of perception is action. And when we perceive something in our environment, that information is going to promote action in the world, revealing moment-to-moment changes in our body. And so we see that in how we move our hands and arms in Mousetracking. And you're like, okay, Jenny, that makes no sense. So what does that actually mean? So the way that I explain this to my undergrads is when, so think about this example. Think about you ever being on a diet. Imagine somebody walks up to you and says, I just made these warm, fresh chocolate chip cookies. Would you like one? Your initial reaction is to reach out and grab one. And then you're like, oh, wait, no, I'm on a diet. I can't have one. So you move your hand away. And so what that reveals, so like if you ask, did Jenny want the cookie? My final end response says no, because I didn't take one. But if you actually watch my body dynamics that I'm actually moving, it actually shows no, actually Jenny did want the cookie, but she overrode that urge to take the cookie. And so this is really tapping into implicit and explicit processes. And that's what's really important for cognition, because dual process models of information processing assume that there might be two processing paths. One that is implicit, it's quick, automatic, non-conscious, and it's our initial reaction to things. And these might rely on heuristics or mental shortcuts based on prior knowledge to make very quick, rapid judgments. And these are often in Mousetracking revealed very early in responding. And the reason that we have these from a theoretical point of view is that the world is complex. We can't attend to everything. And so we need really quick and easy ways to attend to things or to make decisions about things. Unless something happens in the world that says, no, don't rely on your heuristics, because that's not going to work. And that's where explicit processing comes in. And this is going to be more gradual, somewhat introspective, and it's going to rely on conscious processes with our implicit reactions. So environmental cues often trigger us to exit our heuristic process to focus more on these explicit processes, more thoughtful processes. And these can, when our explicit processes are turned on and kick us out of these heuristics, we can often see indecision reflected in our response patterns and our action dynamics. But also, at the end of this is that, so computer mousetracking is going to help reveal these cognitive processes by capturing continuous trajectory data as participants move towards a decision. And the variability of their patterns in mouse movements are going to provide crucial insights to what is actually happening in cognition as it links to action, allowing us to make stronger inferences about implicit and explicit processing. In some of the work that I've done, I've not only used mouse tracking, but I've used eye tracking together just to have a bigger picture of what's going on. Um, and so um, there's some utility in being able to use mouse tracking to answer some of these questions that we have about cognition, that don't rely simply just on a single press. So I mean, especially if you're studying perceptual aspects of speech perception in general, like how people understand perception, if you're only getting a categorical response, you're not really measuring perception as it is, you're measuring a post perceptual process. And so mouse tracking is really beneficial because it tells you how people get to the response that they're trying to make. Okay, so moving on, away from towards the theoretical stuff, but as it relates to how we're measuring things in mouse tracking. And the first one I want to talk about is cognitive competition. So cognitive competition is one of the most common measures that we get from computer mouse tracking. There are a bunch of them, but the most common ones are cognitive competition. And those are typically reflected in measures of area under the curve and maximum deviation. So area under the curve is just the space that falls under the curvature of the mouse. The larger the area under the curve, the larger the cognitive competition. Maximum deviation is the furthest pixel point away from the idealized straight line trajectory. And that is also a measure of cognitive competition. And these two measures are correlated. And really, I mean, I don't have a recommendation of which one to pick. I usually use area under the curve, but you can use maximum deviation if you prefer. The other one that I use quite often is this zigzag pattern that sometimes occurs when people are making a response. And this is a measure of indecision, and it's measured by what is called an X-flip. An X-flip is really just the number of reversals across the midline axis of the computer screen. So that shows like bouncing back and forth. Oh, is it true? Is it false? Is it true? Going back and forth. You can also get measures of velocity, reaction time, or response time. You have to be a little bit careful about response time because you have to make sure that their response time has to do with them actually moving their mouse, because sometimes they will hover their mouse where they click the start button and then shoot straight up. So we have to be careful about response time and the implications of that, but I'll talk a little bit about how to handle that in your data cleaning. But response time is essentially a measure of thinking. So how long it takes someone to make the decision. And so my recommendation, and usually what I do in my studies, is I do sometimes pull multiple mouse tracking measures to get a bigger picture of what's going on cognitively speaking. Okay, so there are some benefits of computer mouse tracking. One is that it's an accessible alternative to, survey-based methods or even just behavioral data that produces categorical responses. We can do it online without specialized equipment. We have a faster and wider reach. So say you have, computers are so inexpensive these days. You get a $200 computer, you got 5 of them, get 5 students in the lab sitting at workstations with headphones, and you can collect data, just with Finding 5. I was collecting data this morning with a classroom of 25 wiggly third graders that, it's a great way to do it where I can, I don't even have to bring computers with me, that there were computers where I was, and I just pulled up Finding 5 on their laptops and they were able to do a study. But also you're able to put mouse tracking studies up on platforms like Mechanical Turk. People are moving kind of away from Mechanical Turk for specific reasons, but Prolific. And so Prolific is a really great way to collect data. I do have some suggestions when we get to it in just a couple minutes about some some things to do to ensure that you're not losing money while you're collecting data, because there are a couple things that participants like to do that we don't want them to do in mouse tracking. But it still gives us an opportunity to collect data very, very quickly. Where it used to take me, months to collect 25 participants in the lab, I can collect data from 25 participants within a day. And so Finding Five really does offer an opportunity to be able to do this type of research. And it's cost effective. So again, there's no need for expensive or specialized equipment. Um, and the other nice thing, just to go back for cost effective, the computer mice are like inexpensive. I mean, I don't know, you can probably buy one for $10, but I'm also going to talk a little bit about the difference between a computer mouse and a trackpad. And so you may not even have to buy a computer mouse. And there are some implications for that in a minute. Okay, so now that I've talked to you about computer mouse tracking, now you're like, well, does it even work, Jenny, if you're doing it in Finding Five? So like I said at the beginning, when the pandemic started, I was like, Ting, we really have to have this alternative to collecting data in the lab. Can you help us? And he goes, absolutely. And so what we did is we attempted to replicate a project that was looking at social judgments about people who stutter. And so the reason I do that is I'm working with faculty in speech pathology who study people who stutter. And something that we know, unfortunately, is that when we experience someone who stutters, if we've never really had an experience with them, we automatically heuristically default to this assumption that they are not good. There's a ton of data, 10 years worth of data saying, when you listen to stuttered speech from someone, people will rate them as less intelligent, nervous, less friendly, lots of different social categories. And so what we wanted to do is we wanted to take some of these survey-based methods that they've used to assess social judgments about people who stutter and put it in a mouse tracking paradigm to see, well, I don't know, is there any way we can get people to stop doing this? Because there's nothing wrong with people who stutter other than they just have a fluency disorder that disrupts what the things that they're saying. Okay, so this project is really looking at social judgments about people who stutter. And because of their speech differences, they are often rated negatively by the general public. But we wanted to know whether or not people can attempt to inhibit their automatic biases to assume people who stutter are not as intelligent or nice or whatever negative quality they associate with people who stutter. Okay, but we also wanted them to change their mind. And so we used a self-disclosure study, or we did a self-disclosure study where we got baseline data, where we presented them with speech stimuli from a person who pseudo stuttered. So they would hear words like shut. And so that would mimic a prolongation that sounded very much like stuttered speech. And then at the end of the first block, we introduced a self-disclosure where they heard the person say, "Hi, my name is Adam. I'm a person who stutters." And that was it. Okay. And so the disclosure cue is where the speaker identifies after the baseline that they are a person who stutters. And we see that the listeners do actually reframe their understanding of their speech patterns after this disclosure, which did in fact reduce their bias, but bias was still present. Listeners were more effective at overriding the bias in cognition. So that was the original study. I apologize. Am I lagging for you guys too? A little bit? It doesn't seem like it. It just looks like it on my end. Okay. All right. So that was what we found in the first study, and I'm going to show you the data for that. But I wanted to compare the lab versus online studies. So the lab study used John Freeman's mouse tracker. The online study used Finding Five, and we did find similar patterns, but the effects were a little bit muted for the online version. But I'll talk about that. Okay. So in the first task, we had 22 participants. And so this is just the final end response. This is related to all of the data that has been collected over the past 10 years, showing that when people who do not stutter rate other people who do stutter, they tend to call them less intelligent. So on the y-axis, it's the proportion intelligent. And so it's it goes from 0 to 1. So we see that in the baseline condition, the person who stutters is rated intelligent less, like close, maybe less than 25% of the time. Okay, but when a disclosure is presented, we see that proportion changes, meaning that they are rated more intelligent, even though it's still under 50%. But it's suggesting that effect starts to go away. So in finding 5, we did the same thing. The design was identical. And again, in the baseline condition, our participants did not rate the person who stutters as very intelligent, but after the disclosure, that changed. So, okay, we've got some replication there, but we expected that to happen. All right, so what happens when you do the mouse tracking? Okay. So the first thing that I want to point out, so this is area under the curve. So we see that higher area under the curve occurred at the start of the disclosure condition. Okay, so what happens? So if you link it back to like this dual process model of information processing, what the theory would say is, okay, if you present a triggering cue, then what it should do is it should recruit cognitive resources to compare their previous response to what they say again, like later. And so we see more cognitive competition occurring in the baseline condition than at the start of the disclosure condition. Okay, so that's making them think a little bit more. That's great. The disclosure seemed to do something to cognition. The other thing is that cognitive competition decreases over time. This is also really positive because what that suggests is that participants from the beginning, even though they're thinking really hard about it, cognitive competition declines over time, meaning it's easier for them to make more positive judgments about the person who stutters. Okay, so then we also see that in finding 5, a similar pattern happens when we're looking at area under the curve over time. We see that, I thought I had another. Okay, so if you see the line between the disclosure and the baseline condition in the very beginning, we see that they have more cognitive competition again at the beginning, but then over time, they gradually decrease. Okay, so what we found in the study is that self-disclosure helps. And this is going to help promote lower negative social judgments about a person who stutters. And this is confirmed by both Mousetracking and Finding 5. We did see initial competition in the beginning of the just after the intervention, where we saw high cognitive competition at the start, especially after disclosure in both studies and platforms. And then cognitive competition is going to decrease over time, also confirmed by Mousetracker in the Finding 5 study. Okay, that's wonderful, but we can't say that Finding 5 and Mousetracker are equal in terms of measuring cognition. There are definitely going to be some considerations that we have to make, but we can confidently say that I feel like I can confidently say that Finding 5 does produce results that are similar to what you would do in the lab. Okay, the first thing is the computer mouse. The computer using a computer mouse is going to produce better results because there's going to be more higher fidelity in the action dynamics. Trackpads, though, are going to be easier for kids. So something that I noticed is that when collecting data with Finding 5 with these kids in this AT&T classroom that we have on Kent State's campus, is that kids don't know how to use computer mice anymore. And also something that we've been running into with our undergrads is they've been complaining a lot. They're like, well, I can't do your study because you require a computer mouse and I don't have a computer mouse. So apparently nobody buys a computer mouse anyway. Now, Herb et al., he has written a couple of papers that says, okay, well, using a computer mouse is ideal. But you can use a trackpad. You just have to recognize that you're going to lose. There's going to be a little bit more noise in the data, or it's not going to as easily capture responding. Another thing is methodologically, when I work with the kids, I have to give them an explicit instruction that when they make a response, they have to keep their finger on the trackpad the entire time, because the natural movement is you click and then you swipe up and then you click on the thing. So you have to give them the instruction. You have to explicitly do this. And so I'm currently in the process of collecting some adult data to see if I'm still able to get the trajectory data that I need just with that simple instruction. So my recommendation to you right now is either pilot it with, using the trackpad. If you're going to have them in the lab, it's different because you can tell them. But if you're doing it over the internet, I would recommend piloting it first to see if these instructions work. If not, I would recommend that you tell the participants that they need to use a computer mouse instead. But you have to get them to verify. Okay, we tell them in the instructions, please do not begin the study unless you have a computer mouse. And they start the study, and then we say, hey, just in case you don't have a computer mouse, please go get one now. And then they say, okay, I've got one. And then we say one more time, can you please let us know whether or not you have a computer mouse? Because if you don't have a computer mouse, we need to know because we need to exclude your data. And like 20% use a trackpad. So it's really, really important that you are asking them multiple times the type of device that they're using. And we have actually just been playing around with conditional checks. So this allows us to screen out incompatible devices. And so one of the things that we do, especially on Prolific, is if we tell them, like, please don't start the task if you don't have a computer mouse. And then we go through the series of questions like, hey, make sure that you're using a computer mouse. If you don't have one, please go get it now. And then we ask them again, please tell us the truth. Are you using a computer mouse or a trackpad? And if they click trackpad, then they get kicked out of the study. And then that helps us not, lose a ton of data that way. So there's definitely something, and that has seemed to work. That has seemed to work quite effectively in Prolific. Okay. Another thing that makes Finding Five a little bit different than Mousetracker. So this is kind of an example of what Mousetracker would look like. I'm looking at it here. It's not quite centered, but that's my fault. So I created this. But what happens is the start button is always located at the very bottom of the screen. And then you've got the response options in the top left and right-hand corners. And so what this format does is it gives you a wider range of pixels to sample from. But in Finding Five, the setup is more like this. Okay, so in the Ferguson et al. Study in lab, versus the one on Finding Five, this is the difference between the screens. But we still saw similar action patterns in terms of area under the curve. And so just keep in mind that you will lose a little bit of range in responding with the Finding Five setup. The other thing that makes Mousetracker a little bit different is that in Mousetracker, there is a response that is programmed in that if a participant does not initiate their mouse cursor within 1,000 milliseconds of the start of tracking, at the end of the trial, they will get a notification, please move faster. We don't have that in Finding Five. So one of the things that we do is we tell them, please move your mouse cursor as fast as possible. The other thing that we do is like post-processing when we're looking at the data. Any response, any trial that has a mouse cursor initiation time longer than 1,000 milliseconds is automatically excluded. And so you also want to make sure that you're excluding trials that are less than about 100 milliseconds. I'll talk about that because that does sometimes happen. But I don't think it's like really an issue with Finding Five. I think it's just a network issue that the participants are having with their internet. Okay, so what I've done, I have an experiment building tutorial, a mouse tracking tutorial using Finding Five. So please, I'll give you just a second if you want. Take a picture so you can have access to that, but also you'll have access to the slides too, so you can come back. But it's about a 16-minute video that creates a very short mouse tracking study. Okay. All right, so the other thing with regards to start button placement, with regards to what's going on the screen, is using proportions. So there is a feature when you're setting up the mouse tracking to set the screen to a proportion instead of pixels. That's really helpful because when people have different screen sizes, what we were first doing in Finding Five is we were asking them their resolution, but nobody knew. Or it wasn't helpful. And so Ting and the team were able to calculate the proportion of pixels instead of the actual pixels. Also check for screen compatibility. So ensure visibility of the start button without scrolling, and especially when there's different screen sizes. And we want to push the start button down. So there's no way right now to set where that start button goes. And so the workaround with that, and you see it here, is we create a blank picture and we make it just big enough to push the start button all the way down where we want it to be. But sometimes if you push it down too far, it means the participant has to scroll down. And so what I would recommend you doing when you're piloting your study, before you put it up to collect data, is put it on a regular computer, like a regular laptop. But then if you've got a dual screen, put it on the dual screen and check them on both to make sure the participant is not having to scroll down. Okay. There are also some data quality considerations. I would highly recommend that you oversample as much as possible. So if you're familiar with the Brisbane and Stevens 2018 paper on sample size for cognitive studies, we're highly undersampled in most of our studies anyway. So I would just recommend going at least 2 to 3 times more than you would normally sample. And the reason that is because participants will do that thing where they say they have a computer mouse and then they'll get 3 questions in and go, fine, I'll tell you that I'm using a trackpad. So in the study, the original study that we replicated, we only lost 2% of the data. This was in the beginning. Now we're losing like 20 and 30% of the data because participants are not using the appropriate device. I'm hoping that we can move away from using a computer mouse, but we're still kind of testing to see if that's okay. It's going to work okay for just using a trackpad. Also, we want to make sure to exclude invalid trials, and that's one, they're using the wrong device, or delayed mouse cursor starts, or extreme response times. Sometimes it's super important when you're doing any of this mouse tracking stuff that you are checking the initiation times as well as the trial response times. Anything longer than a couple of seconds for their response, like I would not really go past 5 seconds to give them to respond. I usually go between 1 and 2,000 milliseconds in terms of making a response, because anything past that, you're not really measuring implicit cognition anyway. You're measuring that post-perceptual response. And that can, if you want more a citation for that specifically, I would just go to the Freeman and M. paper, 2010, which is at the end of the slide anyway. Okay. And then again, setting thresholds for data cleaning. And then what else do we do? Is there anything else? Yeah, so anything less than 100 milliseconds, or anything less than 100 milliseconds, I would also get rid of in the data cleaning process, or even just subsetting if you're using R, using some type of filter in R before you enter everything in. Okay, so when you go to when you get the data, it was wonderful. Ting worked really hard with the team to get the data clean and everything printed out into a long format where it's, it happens in a linear time frame of like at every point in the experiment what happens. But what that means is that you've got some data that is kind of intermixed. So the type of data that we put into our mouse tracking studies is we have demographic data, and I usually use text responses, and I do that for filtering purposes because it allows me to filter out all of the demographic data based on response type. And then we've got a choice response, and that's what they clicked on, say true or false. And then it's got the mouse tracking data where it's got the timestamp plus the XY coordinate. And so what we end up doing is we end up creating 3 different types of data. So we've got the demographic data, we have the categorical data, and then we have the mouse tracking data. And so what we do is we separate them out and then do some computations on the raw data and then put it all into one file so it's all there. So it's just a little bit of data manipulation. I also created a YouTube video for the data cleaning procedure. So if you want to see how that's done, you can follow this QR code. And again, it'll be available on the slides as well. Okay, so there are some common data issues that you'll run into using Finding Five. One is lost trials. So I think this happens most when participants' internet connections fail for some reason. And what can happen is we just don't get the data at all. This is very rare, but it does happen. And so when you're bringing the mouse tracking data over to the categorical data to align it for analysis, you will see that sometimes there are missing trials that don't align. But in that procedure for converting the data, I think I show you how to kind of problem solve that. So you need to make sure that the trial numbers match with the participant ID. Sometimes there are single samples, and this happens, I think, when there's like some type of delay in response. So there's like something freezes on the screen where the participant hits the start button, the stimulus plays, and then the mouse tracking doesn't record, and all of a sudden they're at the final response. And so that will show up and you'll get an error. So I use Mousetrap to get the mouse tracking, like the computed mouse tracking variables. And when you're processing it, it will say, warning, issues with trajectories. There's like only one timestamp or something like that. That happens. And that's why it's really important post-processing that you're actually excluding trials that are less than 100 milliseconds, because you won't have a trajectory for that one. So to kind of, save yourself against all of this data loss, because unfortunately there is more data loss in online data collection than you would expect in a lab, just oversample. For most of the studies that we're running these days, instead of using, having the days of 20 participants, like that was gone a long time. Like we don't do that anymore, unfortunately. But we try to get upwards of 100 participants in online data, which is so much easier now because we don't have to get 100 people to come sit in the lab to do this. And so it's kind of, you just kind of balance it. It's like either you spend the time getting people to come into the lab or you spend the time just collecting more data. Okay, so why use online mouse tracking? For accessibility purposes, works on Chromebooks, which is great. That means that if you do kid research and you're doing it in schools, most of them have Chromebooks. You don't have to download the specialized software. You reach a more diverse audience if you're using platforms like Prolific or Mechanical Turk. And efficiency, it runs in the background. No dedicated lab computers are needed. This has been great for my doc students who normally they would be in the program an extra year collecting data if it weren't for online data collection. But there are trade-offs because the fidelity is a little bit lower for online mouse tracking. But if you're collecting more data, then you'll be a little bit more resistant to some of the issues associated with that. Okay, and that's it. I think, did I go over a little bit? Maybe we started a little bit late.
No, you're great. Thank you so much, Jenny. Let me bring up everybody so that. Okay. If you have a question for Dr. Roche, please just feel free to raise your hand. Yes, Sumi?
No, I was intending to clap. I'm sorry.
That's all right. Does anybody else have a question?
Or have you tried mouse tracking and you get to a point where you're like, I just don't know what to do in this situation, or I'm afraid to start using mouse tracking, or is this a viable method?
Sarah?
Okay, I'm trying to figure out how to get things work. Okay, I think you can hear me, but I can't figure out how to turn my camera back on. So, hi Jenny, how are you? I hope you're nice to hear from you. So I'm curious about like what kinds of like things you could do in conjunction with. We just got a gaze point eye tracker. It was not my idea to get that, but it was the cheapest. Do you have like thoughts about like what kinds of studies that could be done maybe with Finding Five or and gaze point together or both, or for undergraduates especially, where like that maybe what is like
Yeah.
that, like do you have just ideas?
Yeah, I mean, really anything. I mean, any of the tasks that we have, any type of categorical response from participants, you can do with mouse tracking. And I would recommend that, because it gives you richer data. I mean, even if it's just, an identification task or some type of discrimination task, if it's, even low level speech perception stuff. Because some people have even argued like, hey, it's actually better to do it in online platforms because there might be extra noise in the background, because this is just actually how we hear in the world anyway. So it gives you more, real world data. Something that we've done a lot with the undergrads, especially who are doing honors theses, is we take surveys. So surveys that they might be interested, say they're looking at cultural competence or something like that. And we actually take the surveys and we turn the Likert questions into categorical responses. Something else we do is, because it's like, well, okay, does it really match what's on the survey? So we'll do the categorical responses, but right after you can also program a linear scale. Like there's some tweaks that you have to do to make it look nice. But thank you, Noah and Ting for getting rid of the tick marks that made it impossible to see. But so you can kind of use it for survey data if you want to, replicate something, but you have a better idea of how people are making those responses. We do a lot of stuff with like vocal affect, looking at social judgment. So that's a lot of what I do. But really, I mean, anything.
Okay. Do you have like are there good open source like data, like if you made your data cleaning available so that they can, because I mean like area under the curve doesn't sound, it's not going to sound accessible to our students who don't have calculus, or and I imagine that you don't actually are doing calculus.
Yeah, no, I don't know. I don't. Yeah, no, I don't. That's a little bit beyond me. So there's a Mousetrap program in R that will do all of it for you. I'm also happy to share. I wonder, I might have it. I might actually, so all of my data that I use mouse tracking for is posted on Open Science. I could also create a page, or maybe just give it to you, Ting, where I give you the R script for the processing, the data processing.
Yeah, I can distribute your slides and any kind of script to everybody
Yeah.
attended. Yeah.
And it's super easy. You just load it in. It's there. So I gave you guys a video. If it's linked on, let's see. Here. If you scan this QR code, it will bring you to the video for data cleaning and processing. But it's really not hard. I mean, it's really, really not that. It takes time in the beginning when you're trying to figure out the data structure. But once you figure it out, I can clean data from 100 participants in about an hour and a half. And that's with getting the mouse tracking variables using the Mousetrap program.
A tongue twister.
Yeah. But it's great. I'm actually with my lab in the next couple of weeks. We're my PhD advisor when I was in grad school. We used to have something called a Geek Fest where we would get around and like eat pizza and like code. And so what I'm going to do sometime in the next couple of weeks is get all of my undergrads together in the lab, and I'm going to order pizza and I'm going to go through the crash course with them in Finding Five.
Awesome. Cool. Yeah. Thanks, Sarah, for the question. And just want to check with the rest of the crew. Does anybody else have any questions to ask about mouse tracking? or anything just relate. Yeah, sorry. Yeah.
I think it was my dog barking.
I don't have a question, more like a comment. That coming into this, I kind of thought of mouse tracking, like the way you kind of framed it at the beginning, as like poor man's eye tracking. But I think after you went through your presentation, I'm starting to feel like that isn't the case necessarily. There's actually applications where there's advantages to doing mouse tracking over eye tracking.
Sure.
Like specifically in like decision making stuff, it looks like it yields a lot more and possibly better quality data than eye tracking would. And even eye tracking itself, even though it might be the champagne of tracking as opposed to the beer of tracking, um, like there's problems with that too. Like the relationship between gaze and attention. Is that real? That's what is that? There's a little bit of controversy about that even, and this seems much more intentional as well. Like no, and your side about perception and action, that's different than gaze, just cognitively, and it may be actually in certain circumstances better, so to speak, than eye tracking for certain applications. That's kind of what I got out of this.
No, and I agree with you that there are definitely times that I would choose mouse tracking over eye tracking. I could use eye tracking in these social judgment tasks, but I'm really interested in bias a lot of the time. And I don't know that eye tracking would give us what we're looking for in terms of
I don't think it would capture anything like that.
No. Right. So you're absolutely right. So it really depends on the task that you're looking to do. And so I think you're right that and I think you're right to not underplay the importance or the benefits, the measurement benefits of using mouse tracking. That we call it the poor man's eye tracker, but you know what? It's pretty powerful to answer some really important questions too.
Yeah.
So thanks for adding that.
Yeah, and just to piggyback on Stan's comment, there's one point that I only realized thanks to this talk is that you want people to start as fast as possible because only the initial period of moving the mouse reflects the implicit sort of cognitive process, right? If there is a huge delay between the presentation of the stimuli, by the time the participants start making the decision, taking the action of moving the mouse, that particular action is mostly just reflecting the post-perceptual outcome. Or, yeah, and I think that is something that a Finding Five can do better, right? So we can introduce some kind of a mechanism to force, like Mouse Tracker, the program John Freeman has created, to encourage the participants, if they did not do so well on the previous trials, to make sure that they sort of keep up the pace, right? In order for the mouse tracking paradigm to actually measure what we as cognitive scientists are interested in. That felt like a lightning bulb in my head. Finally turned on. Yeah.
One thing that I do, just because it's not there at the moment, it's a workaround. This is, so Ting, this is something that we used to do before we had John Freeman's mouse tracker. We would just say, this is what we would tell participants. If you want to get out of here faster, respond faster. And so that's one way to handle it, is to say, like, if you want to be done quickly, respond quickly, because we do want them responding as fast as possible. And we tell them, begin moving your mouse cursor as soon as you see the response options and don't wait. And so having some of these little, bits of advice of telling say, like, if you do this, you're going to get done faster. And it motivates them to do it quickly. Something else that I didn't say, I think that I probably should say, I would not run studies that are longer than about 15 minutes. 15 to 20 minutes, just online, because you will actually start seeing them not doing what you need them to do.
Cool. Yeah, that's actually a problem with almost all online studies. Anything that that stretches to 30 minutes, the data quality just drops off a cliff.
Yeah.
Right? So the sweet spot is probably 15 minutes. I'm just speaking out of my yeah, but I like heuristically, I have heard researchers are happier with shorter studies rather than longer ones.
Something else to consider too. I mean, there's lots of different. I'm also happy to answer anybody's questions. Please feel free to email me too if you're like, Jenny, what do you do in this situation? If you're using pre-recorded utterances, it's also sometimes helpful to add silence at the beginning of the utterances to make sure that they play for the same amount of time.
Mm-hmm.
So that the response options pop up at the exact time that you know, so that they're not, some aren't longer than others.
A good point. All right, I think we are almost time. We're actually exactly time. If anybody has any follow-up questions, you can email Jenny, or you can email us, right? So and we can forward your email to Jenny. Thank you so much for giving this wonderful webinar, Jenny, and thank you everybody for attending. We're looking forward to connecting with each other, and you know where to find us, right? Thank you so much.
Thank you.
Bye.
Thank you.
Bye, everyone.
Bye.